We've already talked about how things such as air temperature, altitude, and humidity affect your Skyhawk's performance. Now let's look at performance factors that are hard to quantify as they apply to maneuvers you encounter in every successful flight, takeoff and landing. As you know, it's every pilot's goal to keep the number of takeoffs exactly equal to the number of landings. What you're about to learn could contribute to that noble ideal. Thus far, you've been flying from some kind of improved surface, probably concrete or asphalt. Well, sometime in your flying career, it's likely that you'll encounter surfaces that are less satisfactory. These could include dirt, grass, gravel, sand, loose and hard packed, crushed rock, pierced steel plank. You get the idea. They have one thing in common: unpredictability. It is practically impossible to hang any numbers on what they might do to performance. But what you can be sure of is that they are not going to improve performance. Since formal data are lacking, about all you can rely on is the experience of others and your own common sense. If in your mind there is even a hint of doubt about a takeoff or a landing, don't. Now, even runways with improved surfaces may have pronounced slopes or gradients. Again, no data are available for small airplanes like your Skyhawk, but instinct tells you that an uphill takeoff or a downhill landing are unlikely to improve performance. So here's another case where you'll need to depend on local knowledge and the experience of others. And don't forget that experience is another way of saying learning the hard way. Well, enough about the unknown or unmeasurable. Here are a couple of airspeed definitions that are both known and measurable, and important when you're taking off. The first one is best rate of climb, or VY. You're already familiar with it because you've been using it in your pattern work. Best rate of climb is the speed that results in the greatest gain of altitude over a given time. Back in the lesson on emergencies, we discussed that altitude gave you the most options. By employing VY, you cut down the time when your options are most limited. VY decreases with altitude. At sea level, it is 79 knots indicated airspeed. The exact numbers can be found in the POH, figure 5-6, which we'll discuss later. But suppose there's an obstacle in your takeoff path. Doesn't matter how fast you climb if you don't clear the obstacle. That's where the best angle of climb speed, or Vx, comes in. It's the speed that results in the greatest gain of altitude over a given horizontal distance, and it's always slower than Vy. Vx is given in the notes just above POH table 5-5. At sea level, it's 57 knots indicated airspeed. There will be a more detailed discussion on Vx in a future lesson. This sketch offers you a rather vivid handle on the difference between Vx and Vy. And if you're having trouble remembering which symbol is for best angle and which is for best rate, well, just keep in mind that X has more angles in it than Y. And at this point, you should have a pretty good angle on a few things that can affect your performance at an airport or flight strip.